Have you ever thought about this? What if learning something new made you forget everything you already know? Sounds like something out of a sci-fi movie, right? Well, for artificial intelligence, it's not fiction. It's a real and, frankly, bizarre flaw. Today, we're going to dive into why teaching an AI can sometimes, well, break its own mind. Just imagine a world-class musician, okay? They spend weeks learning a new piece by Mozart, and then poof! The moment they master it, they've completely forgotten how to play Beethoven. All of it. Gone. It's just a crazy idea, isn't it? I mean, that's a total breakdown of how memory is supposed to work. But here's the thing. For an AI, this isn't just some wild hypothetical. It's a very real problem, something that has kept researchers scratching their heads for decades. And it has a pretty dramatic name: catastrophic forgetting. So what is catastrophic forgetting? Well, when a typical neural network learns something new, it doesn't just neatly file that new information away. No, the very act of learning can suddenly and completely wipe out what it knew before. We're not talking about memories just fading over time. This is an instant total system wipe.
And this wasn't some problem that AI developers saw coming. Not at all. It was a glitch they just stumbled upon. Almost by accident, really. And it happened during some surprisingly simple experiments way back in the late 80s.
Okay, so let's set the scene. It's 1989. You've got these two researchers, McCloskey and Cohen, and they have a pretty straightforward idea. Can we teach a neural network some basic math? Kind of like how a kid learns their addition tables in elementary school. The experiment they came up with was just beautiful in its simplicity. Here's what they did. Step 1. They trained the AI on ones addition facts. 1 plus 1, 2 plus 1, 3 plus 1, and they kept at it until the AI had it down cold. Okay, step 2. They did the exact same thing, but this time with twos facts. So 1 plus 2, 2 plus 2, and so on. Now, once the AI was a pro at the twos, they went back and tested it on the original ones facts. So, what do you think happened? Well, it was a total disaster. The AI's memory of the ones facts wasn't just a little fuzzy. It was practically gone, vanished. The new information had basically just paved right over the old stuff. I mean, even after just one round of training on the twos, all that previous learning was just scrambled.
So the big question is, why? Why does this happen? What is going on under the hood, inside the machine's brain, that causes such a complete and total memory failure? Okay, so the main culprit here is something called overlapping representations. See, in these networks, information isn't stored in nice, tidy folders like on your computer. It's spread out across this whole web of connections. So when new information comes in, the network has to change those very same connections to learn it. And in doing so, it basically just scrambles the patterns that held the old memories. Here's a good way to picture it. Imagine the AI's entire memory is like a single point on a giant map. This map is called the weight space. To learn the ones facts, it finds the perfect spot on the map. But then, to learn the twos facts, it has to pack up and move to a totally different spot. The problem is, it forgets how to get back to the first spot. It's like it just loses the old address.
So you can imagine, this discovery sent a shockwave through the AI community. It kicked off this huge quest because everyone realized, hey, if we're ever going to build machines that can learn continuously, for their whole lives like we do, we have to solve this memory problem.
And over the years, researchers have come up with some really clever ideas. They basically fall into three main strategies for fighting this catastrophic forgetting. You can think of them as making the AI rehearse, building it a better brain, and actively protecting its old memories.
All right, so the first idea is probably the one you'd think of first, rehearsal. It's basically like giving the AI flashcards. So as it's learning new stuff, you also make it go back and practice a little bit of the old stuff. It's pretty simple, right? This keeps those old memories fresh and stops them from being completely erased. Okay, the next approach gets a bit more complex, and it actually looks to biology for inspiration. See, our brains are pretty good at this whole memory thing, and one reason is we have two different memory systems that work together. We've got the hippocampus for learning new things fast, that's our short-term memory, and the neocortex for stable long-term storage. So researchers thought, hey, what if we tried to build an AI that works the same way? And this image here shows that idea perfectly. This is what's called a pseudo-recurrent network. You can see it has these separate parts that are designed to copy the brain. There's an early processing area, that's like our hippocampus, taking in all the new stuff. And then there's a final storage area for the long-term knowledge, kind of like our neocortex. The real magic, though, is how they talk to each other. They interact. which lets the AI learn new things without destroying the old.
And one researcher, Robert French, really put it best. He said that this interleaving, this constant mixing of old and new information, is absolutely crucial. You can't just lock the old memories in a vault. They have to be part of the process when you're learning new things. That's the only way it works.
All right, on to our third strategy. This one has a cool name, elastic weight consolidation, or EWC for short. The best way to think about this is like a memory protection system. The algorithm is smart enough to figure out which connections in the network are the most important for an old skill. And then it sort of protects them. It makes them stickier, so they're much harder to change when new information comes along.
So we've got all these clever solutions, right? And they actually work pretty well. But, in the world of super complex systems, sometimes when you solve one problem, you accidentally create a brand new one. And this one has a really ironic twist.
It turns out, by getting too good at preventing forgetting, researchers stumbled onto something new, catastrophic remembering. Yep, it's the complete opposite problem. The network gets so good at holding on to its old memories that it starts to see those old patterns everywhere.
What happens is the AI basically becomes rigid, It gets stuck in its ways, it overgeneralizes from everything it's learned in the past, and it loses the ability to tell the difference between something it actually knows and something new that's just kind of similar. It's like having this extreme case of déjà vu all the time, where nothing ever feels truly new.
And all of this really gets to the heart of the challenge in building AI. It's what's known as the stability-plasticity dilemma. It's this constant balancing act. On one hand, you have plasticity, that's the ability to learn new things, but too much of that, and you get catastrophic forgetting. On the other hand, you have stability, the ability to hold on to what you've learned, but too much of that, and you get catastrophic remembering, where the AI just gets stuck and can't learn anything new at all. It's a constant tug of war.
So, when you boil it all down, the ultimate quest is to find that perfect, delicate balance. How do we create an AI that can learn for a lifetime, just like a person, without either erasing its past or becoming a prisoner of it? Solving this isn't just about fixing some technical bug. It's about getting to the very nature of what intelligent memory really is. And that's still one of the most exciting and important frontiers in all of AI research.